And I'm going to talk through an Excel file here for you and show you how these data can be calculated using Excel. And this is a file that I'll put, the title of this file is Decision Analysis Examples, and I'll put this up on D2L at the end of class. And this is how we can use Excel to quickly calculate this. And what I'm going to do is I'm going to actually I'm going to come over here and I'm going to delete these just to get us going and show us how this works. Now, of course, here we've got this is our data, which we've seen before, and we've just typed in and entered this data. So again, as we've seen so many times, the apartment, for example, returns $50,000 and so forth. So this is the data that we've seen. Now, if we, again, were in an optimistic standpoint, the first thing that we want to do is we want to collect and determine what's the best of the best. And so we want to use the function. And again, if you remember, when you type an Excel function, start with an equal sign, and we want to calculate the maximum of these three cells that correspond, those returns that correspond to the apartment. And we close the parenthesis, and of course we know for the apartment that's 50,000. The beauty of Excel is that if we highlight this indicator when the little plus, when the dark plus sign comes up, if you get the dark plus sign and then click and drag that down, that formula gets dragged down into each one of those cells. And so this figure, of course, is now the maximum of the office returns, and then 30,000, of course, is the maximum of the returns for the warehouse. And then in the payoff here in this cell, which is H12, again, we've got another maximization function in which we choose the maximum of those three values above. So, of course, that's 100,000. And then we do a little formatting. Again, we can put the thick bottom border under there. And now we've formatted that. And so we know that the payoff is the best of the best. Optimistic payoff is 100,000. This is another formula that you can use. It's called VLOOKUP formula in this cell. And I'm not going to go into that, but you can certainly Google that and find out how to use that formula. It's a very handy formula. So we know for the optimistic viewpoint, the return is $100,000, and we know that the decision is to the office. And now we're going to do the same thing for the pessimistic, although in this case, we're going to choose the minimum of these three cells. And of course, for the apartment, the minimum return is 10,000. And if we there we go, drag that down, then we know that the minimum is 50,000 and 10,000, loss of 10,000. And so the maximum of those is 10,000, and the decision, of course, is the apartment, and we want to do that. So that's the process and the formulas to use for the optimistic and pessimistic. Now let's look at the regret table, and this area here is our regret table, and the first thing that we want to do is to determine the maximum values for each of our economic conditions. And so in this cell, and this can be anywhere, we want to choose the maximum of the economic conditions. And we'll delete this. And again, once you get that formula, you can drag that across and you get the maximum for the fair economic conditions. And of course, the 15,000 is the maximum for the poor economic conditions. Now we want to build our regret table. And in this cell, we want to calculate the maximum value minus every one of these three values and make them correspond into those cells. And so for the first cell, you can see it's this value 100,000 at C17 minus this value of 50,000 in cell C9, and so forth. Now you might ask yourself, what's this dollar mark here in this 17? And 17 means that the dollar marks are fixed reference cells, and the dollar mark in front of 17 means that the 17 corresponds to the row. So we want to keep this row the same as we make copies. So if we copy down, we want this C17 the column will stay the same, but we want also the row to stay the same. But in any case, you don't have to use the dollar marks, but you should be careful about how you build your formulas. And of course, here in this cell is another example. We've computed 25,000 minus 20,000, which leaves the $5,000 for our regret for the combination of office and the fair economy, and so on and so forth through this table. So this is our regret table. And then over here in this group of cells, much like before, we want to determine for the apartment, for these apartment returns, which is the maximum value. And of course, we're going to use the maximum function again and choose, and then copy. And then from among these three, we want to choose the minimum. And now we've chosen the minimum. And so we know that the regret that we want to avoid, the maximum regret that we're going to be able to avoid is $50,000. And in this case, the recommendation again is the apartment. Again, to notice each one of these columns has a zero value in it. And all of these values in this cell are positive. Okay, so that's the regret. And then next, we want to look at the equally likely. And the equally likely process, all I've done is oh, there's a mistake here. This should be minus 10,000. This should be minus 15,000. Oh, not minus 15. My apologies. 15,000. Positive 15,000. Okay. Now we're set. So and again, we've just copied down the returns respective for the each one of our combinations of economy and decision. And in this cell, we're going to introduce a new formula. And this formula is called the sum product formula. And so in this cell, we're going to calculate equals I'm going to put this value into this cell. put value into this cell. Okay, so this is the sum product function. So make this a little bit more clear. Here's the sum product function that corresponds to this cell. And again, you see what that does is this takes this first array of C29 to E29, which is the blue array here, and it, first of all, it multiplies the respective values of the cells. In other words, 1/3 times 50,000, and then it adds those products together, so it sums the products. And so, this is a much more efficient way than simply typing in a longer formula, which would look like this. Now, you certainly could do this by saying this is cell 50,000 times this cell plus this cell times this cell plus this cell times this cell. That would return, clearly is going to return the same value. But the number of keystrokes that you make is very many more keystrokes than to simply type sum product, open the parentheses, type the one array that you want to use, and then hit comma, highlight the other array that you want to use, hit enter, or close the parentheses and hit return. And again, there's the figure. And of course, you can go back and format this. You want to have fewer decimal places. You might want to make this currency and so forth. So again, and the other thing about this is that this formula, we can use this if we were to take this formula and drag it down. We get a problem, because you'll notice the original formula here, it's step one, if you will, 28,333, and it's the red array with the blue array. Well, in this case, as you drag it down, both the red array and the blue array move down one step, but that's really not what you want. If you were to drag it down, you'd want the red array to stay in the same place and not move. So this is why you would use the fixed reference values, because you would want your red array, in this case the row 28, C28 to E28, to stay the same. And to do this on a PC, you would hit function key F4. So you would hit function key F4, and it would automatically insert those fixed location indicators. And if you hit F4 again, it would fix the row locations. If you hit the F4 again, it would fix just the column locations. And if you hit F4 again, it's back to no fixed locations. But we want to keep those the same. And now when we were to drag that formula down, again, these formulas then would be all the same. So I would strongly recommend that you use this sum product function for your work whenever you can. All right, so let's go over and look now at the Hurwitz criteria. The Hurwitz criteria here, again, we are going to use the sum product function, And you'll notice here the Hurwitz criteria is 3/4, and the 1 minus alpha is 1 minus that value. So that way you can change these values. Let me finish the function. And then again, here we've got another sum product function. And in this case, it's our alpha and 1 minus alpha values that are going to be multiplied with the optimistic value and pessimistic value for each one of these decisions, and then added together. And so you may remember, so this is for the Hurwitz criteria, the apartment was 40, the office was 62, and the warehouse was 20,000. And again, in these cases, you want to make sure that this blue array doesn't move when you drag down the formula. And so you insert the fixed reference, fixed location indicators. The reason that you want to use these formulas, two reasons. Number one, it's very accurate, and number two, it's faster, fewer keystrokes, less chance for error. And then number three, if, for example, you wanted to, let's suppose, well, instead of a decision maker, she was not, she was feeling a little less optimistic, but she was 60% optimistic. Then instead of 0.75 or 3/4, you enter 0.6, and then automatically those figures are updated. Or perhaps she's only 40% optimistic and 60% pessimistic, or just the opposite. And you can change those very quickly and get the correct answer by using those formulas. And so you can see now in this case, if the decision maker were 25% optimistic and 75% pessimistic, the preferable decision would be the apartment. So that's the power of Excel. All right, so now let's go to our conditions of risk. And again, it's going to be very, very similar, except now in our formulas, we've been able to assign our probabilities, but this function, sum product function, is just what we've done previously. And we use that sum product function. We'll use the maximization function to determine, in fact, that the office is the best. And then for our expected value given perfect information, we calculate the maximum values for each of the economic conditions, as being 100,000, 25, and 15. And then again, we're going to use that sum product function to multiply these three maximum values with respect to the probabilities and add those together. And then simply at the end, we're going to do a quick subtraction, calculate our expected value of perfect information. So there you go. These will be posted and will be available to you to look at, play with, and use for your quiz that we'll have at the end of next lesson. Okay, so I do want to show you one other spreadsheet. And this is going to be posted and available on D2L for you. I'm going to go over this very quickly, but this is the results for that other practice problem that we've been talking about. And you can see that the formulas are, let me blow this up a little bit for you. The formulas are going to be very, very similar. You can see we've calculated the optimistic and pessimistic viewpoint, but again, in these formulas, and rather than being the maximum, we're choosing minimums because these are costs. Then when we get down to the bottom, we're going to choose the minimums of these minimums. And in this case, it's the mini-max. Equally likely, I've just taken the average. It could be the formula could be used was this perhaps like the sum formula of and then divide that by 3. Or the other formula that you could use here would be the average formula. You take the average of these 3 values, and you can see that'll still remain exactly the same. So either way of that is okay. Then in the regret table, again, we'll take instead of choosing the maximum, we'll choose the minimum because they're costs. And then we build our regret table because we're going to subtract. The regret is because it's, if you will, it's negative. So it would be this in some sense, well, not in some sense, it would be the best value minus the, it would be the opposite of the best value minus each one of these values, and then the negative of that, because you would regret your cost regret is in a sense is the difference between what your best return is and what you would miss. And so your regret in the case of if you invested in China would be $5 million when you could have had $3 million. Excuse me, it would have been $5 million because you could have had $3 million, but you actually lost $8 million. You could have only lost 3, but you actually lost 8. So I want you to work through there, and then of course again the minimum of those maximum regrets is $2 million, and that corresponds to the Philippines. And then again, these are calculated using a sum product function. And in this case, each location has its separate probability. And so, in fact, you could just copy this formula straight down and then choose the minimum of those as their cost. So work through this one. Make sure you understand both of those. Both of these spreadsheets will be posted on D2L under lesson 6. Lesson 5 and 6 on D2L. All right. Again, as always, let me know if you have any questions.